Hello everyone, I am Amulya, second year student at KMIT from group G329. Today I'll be presenting my first milestone recording for the project Codegenie. We all know it's really frustrating when we get stuck while coding. Here's where Codegenie comes in. It is an AI-powered VS Code extension which provides real-time code completion and also auto-suggestion using the DeepSeek coding model. It is an offline AI assisted tool which runs locally, which ensures fast and efficient coding, which boosts the productivity of developers. Solving the developers' challenges. So developers often spend a lot of time writing the boilerplate code. Here, CodeGenie auto-suggests and generates code snippets, which boost the efficiency, thereby reducing the boilerplate. Syntax and logical errors. CodeGenie provides real-time error detection and accurate code suggestions, which minimizes the debugging time. And also, CodeGenie understands the context and gives better solutions. And also, there's this limited AI assistance as we usually rely on manual debugging and searching the solutions in the internet, which is really time consuming. So here's where CodeGenie can really help developers. The users of CodeGenie. New developers like students who are really interested to learn various programming languages in a very faster pace. We offer auto completions to learn at a fast rate. And also software engineers who wish to increase the code quality and speed up the code production. Hackathon participants. As we all know, in hackathons, we have to present with the project in a very tight schedule. So it helps team focus on innovation, boosting their productivity. And also open source contributors who need AI's help for improving the code quality. AI enthusiasts who really love experimenting with the AI coding tools. Tech stack and the user roles. So for the tech stack, for the VS Code extension, we'll be using TypeScript, which will be running in the Node.js environment, which is the front end. And for the back end, we are using Fast API to call the DeepSeek coder model, which is running locally. The model, as I said, DeepSeek coder, which has 6.7 billion parameters, which would be running locally via OLAMA. And for the GPU acceleration, the college will provide us with the RTX 4090 for faster inference. And the roles involved in our project are first is the end users, the users who will benefit from our project, which are developers, students, engineers who will use our extension for code generating process. And next comes administrators. Administrators are those who have worked on doing this project, who will manage the extensions updates and focus on improvements on a regular basis. And then comes user interactions and data sets. So here the user writes the incomplete code or prompt in the VS Code editor. This prompt will be set to the DeepSeek coder, which will be running locally. The model generates the code completions, and this code completions, the code snippets being generated, and that thing will be displayed in the VS Code editor. And the data set, the model which we are using is DeepSeek coder, which will be running locally via OLAMA. So this model is really trained on a very huge data set, which includes open source repositories, Stack Overflow, GitHub, and also on various lead code problems. Cloud deployment as of now is not required as it is running locally. In future, we may opt based upon the preferences given by the user and also the feedback, also on the scalability if required. The architecture diagram. So our project follows a 3-tier architecture, which involves front end, middle end, and back end. The front end is where the user interacts with the VS Code. He or she interacts via VS Code, writes a prompt or an incomplete code snippet, and then calls the Codegenie extension. The Codegenie extension will send a HTTP request to the DeepSeek coder in the backend, which is running locally. So in the backend, what happens is the prompt or the text which is being given by the user will be taken in and it will be pre-processed. Pre-processing is nothing but the text will be normalized and will be generating into tokens. So those tokens will be embedded. Embedded is nothing but, so those tokens will be converted into numerical representation vectors. So those vectors, and then the attention happens. Attention mechanism is nothing but it finds the context associated with that particular word and it tries to understand which word to focus more on, and then it tries to predict the next word based upon the previous tokens being given by the user. And then it decodes. So the predicted numerical representation, which would be predicted, will be decoded so that it becomes human readable. It becomes into a human readable format. So that thing will be post processed. It's nothing but optimized. Perfect indentation will be given according to the various languages accordingly. And the output would be sent back to the API, and through the API would be sent back to the VS Code, and the same would be displayed on the screen on the VS Code's editor. So this is the architecture diagram of a project. Thank you.